Okay, notes 6.6, placing figures on a coordinate plane. So what we're given here is we're given some shapes that we should be familiar with that are placed on a coordinate plane, and we're asked to find the missing coordinates uh, by using the given coordinates. Now the coordinates you're given are very generic, and they're represented by variables. For instance, this first example is a rectangle, which means opposite sides are congruent. We have 4 right angles, opposite sides are parallel. So we're going to use that information to figure out the missing coordinates. Now, the coordinate we're given is coordinate L right here, and this point has coordinates AB. Now, A is the x coordinate, and B is the y coordinate. So we can pretty much start wherever. I'm going to start over here at point M. How would I get to point M from the origin? I would travel down the x-axis to this point, and then I would go down to coordinate M. Now the x-coordinate is the same as L's x-coordinate. So I know that M has the same x-coordinate as L. So it'd be A. The y-coordinate is negative because we went down. L's y-coordinate is positive. Now we went up B units, so that means M's y-coordinate would be negative B. Coming over here to point K, how do I go from the origin to point K? I'm going to travel along the x-axis, and going left means that the x-coordinate is negative. And how far did I go? Well, it's going to be the opposite of where I went to get to L or M. So positive A here, that means negative A is here. So my x-coordinate for K would be negative A. And then I travel up to this point, which is the same y-coordinate as before, which is positive B. Going over here to N, N has the same x-coordinate as K did, which is negative A. And this time we went down like we did for M, so it would be negative B. Let's try this second example. Over here, we have a rhombus. And we are given a couple of different points. We're given point R, and we're given point P. And we're asked to find point Q. Now the one thing I can figure out right away is that the y-coordinate for Q, the y-coordinate, would be the same as R. So I know the y-coordinate is C. Now your x-coordinate is a little trickier. From the origin to get to point Q, I travel along the x-axis to about right here, and then I would travel up. Now I know from the origin to point P has an x value of S, which is given in its point. Okay, but I have some extra room here. I got to figure out what that length is. Now this length here, from point P to where I need to go to get Q's x-coordinate, looks like it's the same as going to point R. So from the origin to point R, which is right here, looks like it has a x-coordinate of B. So how do I combine the B and the S to get all the way to where I need to be? I would take S, and then I would add B to it. So the coordinates for Q are S plus B, and the y-coordinate would be C. In our next example, we have a quadrilateral that's put on a graph, and we're asked to find the coordinates of the midpoints, and those points are T, W, V, and U. So what we're going to do is we're going to find the midpoints of the segments. So my first segment here, I have OA. So figure out the middle segment OA, I'm going to use the midpoint formula. Now the midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So I know the origin always has coordinates of 0, 0, so I'm going to use 0, 0 and the coordinates for A. I'm going to plug them into my midpoint formula, and I'm going to calculate, I'm going to figure out the coordinates of that midpoint, which is point T. So the midpoint T, I'm going to simply use the formula over here, and I'm going to label my points here. I know 0, 0 would be x1, y1, and this point over here would be x2, y2. Now I plug them into the formula. So over here we have x1 plus x2. So that would be 0 plus 2a. And over here would be y1 plus y2. So that's going to be 0 plus 2b. Now if I go ahead and try to simplify this, 0 plus 2a, well that stays as just 2a over 2. And 0 plus 2b is 2b. And again, this is still over 2. And finally, I'm going to look to see if I can reduce or divide, and 2 divided by 2 is 1, so those actually cancel out, giving us a, and these 2's cancel out, giving us b. So I know that this point right here for t is AB. Now I'm going to repeat that for the rest of these points. Let's go ahead and find U. So I'm going to find the midpoint of OE. And the middle of that point, or the middle of that segment, is point U. So I'm going to use the same formula. I like to put my 2's underneath right away. So x1, this would be my new x2 and my new y2. So let me go ahead and get rid of those. So let's plug our points in. So x1, x2. So it's going to be 0 plus 2e, and then it would be 0 plus, in this case, 0. Simplify the top. 0 plus 2e is 2e. And 0 plus 0, well, that's 0. Sorry, this is u. So the midpoint, u, of segment OE, if I simplify, those cancel. The x-coordinate is e, and 0 divided by 2 is 0. So the point for u would be e, 0. Okay, next we have, let's do w. So I'm going to find the midpoint of segment AC. And that midpoint is already labeled as W. So, repeat the process again. Oh, made a mistake here. Cancel that out. My apologies. Okay. This is again all over 2, all over 2. So, alright, let me get rid of those. Get rid of those so we know what we're dealing with. Okay. Alright. I'm going to label point A as my x1, y1, and I'm going to label point C as my x2, y2. So, let's plug them in. It'd be 2a plus 2c. And over here we have 2b plus 2d. Alright, now we're going to try to simplify this. So again, this is point W. Now I can't combine 2a and 2c because they're not like terms. However, they do both have a 2. So what I'm going to do here is I'm going to factor out a 2 from both of those. I'm going to divide out a 2, leaving me with a plus c. I'm going to do the same thing for the y coordinate. Both of these don't combine, but they do both have a 2 in common, so I'm going to divide out a 2, leaving you with b plus d. And again, this is still over 2. So our coordinates for w, which is the midpoint of segment AC, these 2's will cancel out, leaving you with a plus c. These 2's cancel for the y coordinate, leaving you with b plus d. So w's coordinates, a plus c, comma, b plus d. Finally, we're going to find the midpoint of CE. So I'm going to pick a new x1, y1, and x2, y2. So I'm going to label C as my x1, y1, and I'm going to pick E as my x2, y2. So I'm finding the midpoint of segment CE, which is labeled as point V. So again, we're going to plug all this into our formula for midpoint, which is up here. So on the top of this part would be 2C plus 2E. And over here we have 2D plus 0. Let's simplify that. And I'm just going to simplify the top if I can. Now these two here, 2C and 2E don't combine, but they do have a 2 in common, so I'm going to factor out that 2, leaving you with C plus E. And over here, 2D plus 0, well that's just 2D. And finally, we can cancel these 2's, so our x-coordinate of point V would be C plus E, and those 2's cancel, giving you a y-coordinate of D. So V's coordinates, I'll write them in here, would be C plus E, D. That's how you find the midpoints using these generic coordinates with variables. The last part of this problem, we're asked to find the slopes of the sides of the shape TWVU. So we're focusing on the blue quadrilateral. So we're going to find the slopes of those sides. Okay, now slope has a formula all in its own. Slope, which we call M, is y2 minus y1 over x2 minus x1. Okay, so we're going to break this down. Let's do the slope of TU. Okay, now looking at slope TU, I know this slope is going downhill, so I know that slope has a negative slope. Okay, so let's plug them into the formula. I'm going to use A and B. This would be my x1, y1, and point U would be my x2, y2. And I'm going to plug that in to my slope formula. So the formula says y2 over, or y2 minus y1. So that's going to be 0 minus b. And I'm going to go ahead and simplify that. 0 minus b is negative b. On the bottom we have x2 minus x1. So x2 minus x1 would be e minus a. Right? E minus a. I can't take away a from e. Those are not like terms, so I'm just going to write that down as e minus a. Here's my slope of that line. I'm going to do the next one, UV. So let's find the slope of segment UV. Now, UV is going uphill, so I know my answer should be positive. Okay? Let me get, oops, I probably shouldn't have done that. Let me put that back on there. That was C plus E D. Okay, let me get rid of this, that. All right, so we know what we're dealing with. Okay, so E and E0, I'm going to make that my x1, y1. And CE plus E comma D would be my x2, y2. Plug that into the formula, y2 minus y1. So y2 is D minus y1 is 0. Simplify that. D minus 0 is D. And let's do the bottom. That would be x2 minus x1. x2 is C plus E. C plus E minus x1 is E. Simplify the bottom. Now, I do see that I have these E's here. Those are like terms, so I can combine those. Positive E minus E, those cancel, and what's left over is C. So that is the slope of that segment UV. And got a couple more to do here, so let me get rid of those. And we're almost done. Let's come over to segment TW. TW is an uphill slope, so I know that's going to be positive. So segment TW. Let's go ahead and plug in our points. I'm going to use T as my x1, y1, and I'm going to use W as my x2, y2. Plug them in. Y2, so I have B plus D minus y1 is B. And let's do the bottom. X2, which is A plus C, minus X1 is A. Let's simplify the top. The B's will cancel, leaving you with D. And over here, the A's will cancel, leaving you with C. So that's the slope of TW. And finally, we are going to find the slope of WV. So W, I will make my x1, y1. And V, I will make my x2, y2. So WV has a slope. Let's plug them in. Sometimes I like to put the negatives in here. These minus signs, so I don't mess up any negative symbols. I like to put them in sometimes. So, all right, on top we have y2 minus y1. So that's going to look like this. D minus B plus D. Now note, this is a negative slope. I know it goes downhill, so that's a negative slope. And we can cancel those D's out. D plus D actually is 2D, sorry, minus B. All over. Let's do the bottom one. All right, we have C plus E is my x2, so this is going to be C plus E minus x1 is A plus C. All right, let's see if we can combine anything. I have a C and a C. That's 2C. 2C. And then we have E minus A. So plus E minus A. I don't know what happened there. My apologies. Okay. See if there's anything we can simplify here. C minus E. Hold on. My apologies. I made a mistake here. Again, I apologize. Put my negatives in there. The mistake I made was when I plugged these in. For instance, on the top we have D minus Now here I have a quantity, so I want to put parentheses around that. B plus D. And over here the same thing. I have C plus E. C plus E. Take away this quantity. So I'm going to put parentheses around that. A plus C. Technically these are negative ones in here, so I'm going to have to distribute that negative 1 in order to make this happen. So on the top now we have D. Negative 1 times B is negative B. And negative 1 times positive D is negative B. There we go. Okay, over here we have C plus E minus, so I'm going to distribute that again, so I have C plus E, I didn't touch that. Negative 1 times A is negative A, and negative 1 times C is negative C. Alright, that works out a lot better. Now finally, these D's cancel out, giving you negative B, and over here, the C's cancel out, giving you E minus A. There we go. Now, what happens is, when you have slopes that are exactly the same, so if you notice, these slopes are the same. That means they're parallel. So I know that UV is parallel to TW. And if you look, these two slopes are the same, so they're parallel. That concludes the notes. Again, sorry about this mistake down here, but hopefully you get a good grasp on how to do this. It is pretty complicated. It's a lot of work, and it's important you show your work so you can get help if you make mistakes.